So this week, there's been a lot of talk about Old Lake, and Intel just had its recent innovation event. This is where they're trying to re-energize IDF, but starting small and then hopefully gradually going to about 3, 4, 5,000 people, the way IDF used to be. IDF was a great conference to go to, so I'm hoping that they do it in person. But with the launch of Old Lake, and just so you know, we just got some new products in, DDR4 motherboards. That's going to be fun to test. After the announcements, Pat did a roundtable Q&A with some of the press. Now, I took a recording. I couldn't get all of the press to sign off on me showing their faces for their questions, so I'm going to say the questions to what they were, and I'll let Pat answer for himself. What's your minimum specification? If you want an independent cloud services provider for home servers, VPNs, or clients, consider Linode and sign up today at linode.com/TechTechPotato for a free $100 60-day credit. A recent Gartner performance report shows Linode's topology offers almost double the database performance per dollar than other public cloud services. So first off, we have to play the Intel intro theme music.
Yeah, thank you. And when we started Intel Developer Forum in 1997, it was always, as I called, the Geek Fest, right? Getting together, talking tech, being very transparent and engaged with developers. And today, we're resuming that spirit, right, with what we did today with Intel On. And obviously, hey, the company has a long way to go to fully get back to where we want it to be. But today was a pretty great show. And pretty proud of the breadth of things that we talked about and pulled together. And we would have loved, and many of you I haven't seen for quite a long time. Anxious to see you face to face, but we'll make this the best we can do today. And hopefully, sometime next year we'll be face to face with all of you. So with that, let's dive in.
And just if anyone was unsure, Pat is all about bringing the geek back. Well, I've got the full nerd. First question from Dan Hutchinson at VLSI Research. He asked, Pat, you've been talking a lot about IDM 2.0. He likes concept. What is it that makes it different from, say, an IDM 1.0? What elevates it above the buzzword status? In this sense, Dan says that he believes that from the IDM fabless fab-like concept, they're just really distinctions with very little difference. Here's what Pat had to say.
Well, for us, when we talk about IDM 2.0, we talk about three legs. One is a recommitment to IDM 1.0, design and manufacturing at scale. Second is, that the broad leveraging of the foundry ecosystem. But third, and most importantly, is becoming a foundry and swinging the doors of Intel fabs, packaging our technology portfolio, and being wide open to engage with the industry at designing on our platforms with our IP, opening up the x86 architecture as well as all of the other IP blocks and graphics and I/O memory, et cetera, that we're doing. So, adding, the second, but most importantly, the third element of that to me is what makes IDM 2.0 IDM 2.0. The other thing I'd add to that, Dan, is, and I use this language inside and outside the company, IDM makes IFS better, IFS makes IDM better, and IFS meaning Intel Foundry Services. And a quick example of both, IDM, boy, my foundry customers get to leverage all of the R&D and IP that I'm creating through my internal design. Right? Foundries have to go create all of that. I get to leverage tens of billions of capital, many billions of R&D, the most advanced components research on the planet, essentially for free to my foundry customers. An extraordinary asset, making x86, other design blocks available for foundry customers. At the same time, foundry is driving us to do a better job on IDM. We're engaging with the third-party IP ecosystem more aggressively, the EDA tool vendors more aggressively. And, for instance, our engagement with Qualcomm, they're driving us to do a more aggressive optimization for power performance, right, than, our more power-centric or more performance-centric product lines would be. So they're making IDM better by the engagement with IFS customers, standardized PDKs and other things. So IDM and IFS, if this really gets rolling as I'm envisioning it to be, they're powerfully going to be reinforcing each other.
Next, we have Timothy Prickett Morgan, affectionately known as TPM from the Next platform. He says, I'm trying to understand the new Aurora system. This is their big supercomputer. The original machine was designed to be north of an exaflop and cost $500 million. Or is that 500 million revenue for Intel? Now it's 2 exaflops, or at least in excess of 2 exaflops. But Intel's got a $300 million write-off for federal systems coming in the fourth quarter related to that original investment. So because Argonne is now getting 2 teraflops, is this the deal of the century? Pat said this.
Yeah, and clearly, the original concept of Aurora, we've had some redefinitions of the timelines, the specs associated with the project efforts, and obviously, some of those earlier dates when we first started talking about the Aurora project, right? We've moved out and changed the timelines for a variety of reasons to get there. Some of those changes, lead to the write-off that we're announcing right now, and basically, when the way the contract is structured, part of it is the moment that we deliver a certain thing, we incur some of these write-offs simply from the accounting rules associated with it. As we start delivering it, some of those will likely get reversed next year as we start ramping up the yields of the products. So some of it just ends up being how we account for and how the contracts were structured. On the 2 versus 1 exaflop, largely PVC, Ponte Vecchio, the core of the machine, is outperforming the original contractual milestones. So when we set it up to have a certain number of processors, and you can go do the math of what 2 exascale is, we essentially overbuilt the number of sockets required to comfortably exceed 1 exaflop. Now that PVC is coming in well ahead of those performance objectives for some of the workloads that are in the contract, we're now comfortably over 2 exaflops. So it's pretty exciting at that point that we'll go from 1 to 2 pretty fast in it. But to me, the other thing that's really exciting in this space is our Zeta initiative, where what we've said is we're going to be the first to Zeta by a wide margin. And we're laying out as part of the Zeta initiative what we have to do in the processor, in the fabric, in the interconnect, in the memory architecture, what we have to do for accelerators, the software architecture to do it. So Zeta Scale in 2027, a huge internal initiative that's going to bring many of our technologies together. 1000x in 5 years, that's pretty phenomenal.
So then it came around to me, and my question was more about the IBM relationship. So I asked Pat, at the beginning of the year with IDM 2.0, one of the key features of that was a collaboration between Intel and IBM. Intel at the time said, IBM's a strong player in manufacturing, in research and development, and there's going to be a long-term collaboration there. But at the time, Intel didn't really say much of what was going on, and we were promised to have more information by the end of the year. So I asked Pat, could he actually add color to that information right now, as opposed to, because we haven't heard anything all year.
Yeah, I don't have a whole lot more to say. So let me just characterize it a little bit. It's one of the things I think you will be hearing more from us before the year's out. But basically, we're partnering with IBM as, think of them as another components research partner with us in advanced semiconductor research, as well as advanced packaging research. So we're partnering with IBM in those areas. IBM is looking for a partner as well on their manufacturing initiatives and what they require for their products and product lines. And we're aligning together on many of the proposals that you've seen, such as the Ramp C proposal, that we were just granted phase 1 of that. And IBM's a partner with us in those areas. So a fairly broad relationship, and you'll be hearing more from us before the year end, I expect.
So next up, Mark Hackman from PC World. He has what he said is a simple high-level manufacturing question. So Intel's statement is all about keeping up and superseding Moore's law. They were talking about Zeta scale going to 1000x over the next decade. Is this something that Intel thinks is going to be unique to them, or how does Pat think that their competitors will keep up the pace?
I think if you think about, I described 4 things today that I think enable us to go at Moore's or super Moore's law. I said EUV is obviously available to the industry, but we're going to be advantaged at high NA, right? The second generation of EUV, right? We said ribbon FET, a fundamental new transistor architecture. And as we look at where we are versus others, we think we're comfortably ahead of anybody else with a gate all-around structure that we'll be putting into mass manufacturing in 24. So we feel comfortably ahead. And I would also say that almost since the planar transistor design, through strain, metal gate, FinFET, Intel's always led in transistor architecture. So I think that we're advantaged meaningfully in ribbon FET. Power via, nobody else has anything like it. So I think we're fundamentally highly differentiated with our backside power delivery architecture. And the packaging technology, I think with Foveros, with EMIB, with OmniFoveros, these technologies are comfortably ahead of where others are in the industry. So if we bring that together, this idea that, now with a multi-tile, multi-chip, 2.5, 3D packaging approach, we're going to, be well above, Moore's Law by the end of the decade. I think we're going to be comfortably ahead of anybody else in the industry. I don't think it's not that nobody else is going to be participating, but I expect as we look at those coming together, we're just going to be adding advantage over these 4 domains as we look out over the rest of the decade. And that's what we've said, as we think about our IDM 2.0, get back to, parity, get to leadership, and then have sustained leadership. We are laying down the tracks for sustained leadership across the process technology. Moore's Law alive and well. As I said in the keynote, until the periodic table is exhausted, we ain't done.
We also had a couple of analysts on the call, and Linley from the Linley Group was also there. He asked Pat about Moore's Law and exactly how Pat is measuring Moore's Law, whether it's the original definition, the sort of second definition we got. Is it transistors per unit area, dollar per transistor, or is it a particular cadence? And he asks, or is it just Intel is still making progress at the same rate?
Yeah, I'm defining it as a doubling of transistors. Obviously, it's going from a single tile to multi-tile. But if you look at the transistor density of a nominal package size, we'll be able to double the number of transistors in that in a sustained way. And trust me, before my TD team let me make those statements today, they analyze this from quite a few dimensions as well. Now, if you click inside of it, we do expect that transistor, if you just say transistor density per unit silicon area, we are in a pretty good curve right now with the move to ribbon FET, with EUV solving lithography issues, power via, solving some of the power delivery issues. Boy, I think the transistor density per unit area by itself, it doesn't give you a doubling of number of transistors per 2 years, but it's going to be in a pretty good curve for the next 10 years is our expectation. When you then combine that with 2.5 and 3D packaging, that's when you go super Moore's Law, and you can start to, I'll say, break the tiles into smaller, more manufacturable components. With technologies like EMIB, we can tie them together, essentially with almost effectively on die interconnect characteristics. You can also do a better job at doing power management, both across die and in die with power vias, so you're not hitting your head on any of the power limits, even though power will be a big issue there. So it really is the combination of the lithography breakthroughs, the power breakthroughs, new transistor structures, but most importantly, the 2.5 and 3D packaging technologies.
So next up, we had Charlie Demersion from Semi-Accurate. Now, I've known Charlie a while, and his question was very, very pointed, because that's standard Charlie fare. But to be honest, it was a question that I think a lot of us had been kind of thinking in the background. It's all to do with how Intel discloses information. So if you've been following CPU launches over the last decade, over the last 2 decades, Intel's always been confident in handing out details like die sizes, like transistor counts, things that might be considered somewhat arbitrary in some circles, but for people who like to keep track of the numbers, it's kind of vital to know exactly what's going on from generation to generation. However, you've probably noticed, and we've certainly noticed, that Intel isn't giving that information anymore, at least not in the same way, in the same channels. And so even, the day before the launch, we're still asking about die area. Transistor counts are a little bit harder to get. But the comment or question that Charlie made was more around, given that given that Pat himself has posted that Intel desired to be more open, more engaging, Charlie and others, we've had trouble trying to get all this information from Intel, and it's kind of gone nowhere. Intel just doesn't want to give it. So in that spirit of openness, is that now going to change? And Pat had an honest answer for him.
Obviously, as we're swinging the doors open wide, we're getting much more engaged, with technology, with technologists, et cetera. I think we're going to be doing a lot more in this regard. These particular comments, I'll say I haven't heard them before this. Feel free to send me a mail, Charlie, with your top 5 that you'd like to see from us and you're not, and we'll have robust conversations. And, I won't promise anything today because I don't, quite know why some of these things people have been hesitant on those regards. But yeah, we want to be, engaged with technologists, developers, and our tech analyst community. So, send me some thoughts here and I'll happily follow up on them.
Next up was a great question from Paul Alcorn over at Tom's Hardware. He asks about investing in fab capacity, because investing in fab capacity is very capital intensive. Lots of money going into fab, it takes a long time. So the issue here that Paul brought to the table was, well, you're investing in fabs in several different places all at the same time and building up capacity. What happens if you overinvest and you end up with too much capacity? I'm going to add here that there have been reports of some fabs operating at 84-85% recently, and those fabs might be losing money. So you really have to keep a fab at 90+% occupied in order to actually generate a good return for the company. But Pat had this to say.
Yeah, great question. And let me, one thing is, obviously we do extraordinary amounts of market modeling, industry modeling, PC growth, server growth, network growth, graphics growth, et cetera. So a lot of that goes into what we call LRP, our 5-year long range plan associated with it. So, we want to have a better bead on where the market is going than anyone else. But then against that, we're applying what we call smart capital. For instance, right now I lust for more fab capacity. Intel has underinvested for a number of years. Intel has always had a spare shell, as we would call it. And this is one of the principles of smart capital, is you always have spare shells. And a shell, right, if you take a modern, let's say, an Intel 20A fab, is going to be right around $10 billion, but you invest about $2 billion in the first 2 years. So it's actually a fairly capital efficient time where you get a lot of time benefit, right? 2 years for only $2 billion, and you populate it with equipment, in years 2 to 3.5 when the fab comes online. So part of our initiative is build shells. Right, get greenfield capacity in place that we can build shells and have more, I'll say, flexibility, right, and choice, right, in the timing of the actual capital build. So one is, get more of these shell capacities in place. Secondly, we also, with our IDM 2.0 strategy, we said we're going to consistently use foundries. And with that, maybe a quarter of my capacity is from my external foundry partners as well. But I'm also going to have tiles that run internal and on foundries, so that I'm going to have flexibility as I move up or down that curve, right, to be able to flex things in or flex things out as appropriately. Third, we've said, we're going to capitalize some of these expanded capabilities, based on government investments as well as customer investments. And if a customer of foundry, let's say, wants to be at 10K wafer starts per week in their capacity from us, wow, that's a whole fab, right? And we're going to have prepays and other contractual relationships with them that offset our capital risk, in a fair way. And this is exactly what TSMC and Samsung and Global Foundries are doing now. So we'll leverage their capacity. Clearly, you've heard in CHIPS Act and the equivalent CHIPS Act in Europe, government willingness to invest in this area. So that's going to help us, I'll say, moderate some of that capital risk. So those are the 3 tenets of smart capital. Now, underneath that, let's say miserably that I have too much capacity, something I can't even fathom, right, for the next couple of years. But let's say that we're actually in a situation that I actually have a little bit too much capacity. What am I going to do? Well, I'm going to go win more market share, right? We've had declines in market share in some areas. We're going to go apply that capital to gain more share back in PCs, servers, and other places. We see that it's capital. Capacity constrained. Go gain share, and we believe we're in a position as our products get better to do that in a very profitable way. Secondly, we'll go gain more foundry customers. Right? We have this, this exciting new business, and right now all of the foundry industry is highly constrained on capacity, so go win more foundry. Or third, I'll go flex more capacity internal from external, right? From our use of external foundries as well. So the strategy that we're setting up gives me extraordinary capital efficiency as well as capital flexibility. And ultimately, all three of the ones I just told you are highly margin generative for the company, whether I'm gaining market share, whether I'm gaining more foundry customers, or moving from external to internal at much better margin structures. So overall, this is how we're laying out our smart capital strategy. And as that comes to scale over the next couple of years, I think it just positions us in a phenomenal way.
Thank you, Pat.
So following on, Marco Chiappetta from Hot Hardware, he had a question more about software integration with the hardware. So we're seeing, for example, with Old Lake, that there's been a very strong collaboration between Intel and Microsoft to get things like Thread Director and the scheduler up and running. Marco's question was about those sorts of engagements together, whether in the future, especially in the consumer platforms, if we're going to have better consumer products at the end of the day, does it require such close collaboration with Microsoft, with other operating system partners, that this is kind of going to go to be the be-all and end-all? And he specifically asked, does that mean Intel's engagement with Microsoft and other OS providers, is that changing? As in, I think he means improving or getting deeper? Or will OS providers affect how processors are designed as we move forward? So if Microsoft makes changes to the OS, does that determine how processors are built going forward? Here's what Pat and Greg Lavender had to say.
So I'm going to comment, and then I'll ask Greg to help a little bit. The case in point right now is what we just did with Intel Bridge technology. And Panos from Microsoft was here, and they took a major piece of technology, right, and are making it now part of standard Windows that they're shipping. And I'll say it's not the first time that Microsoft has done that with Intel, but it's been a long time since we've had that major functionality. And Microsoft and Intel, we're redefining our relationship between Satya and I, and we've simply termed it as virtual vertical. How do we bring the same benefits of a much more intimate, dedicated partnership with each other, right, to revitalize and energize the PC ecosystem? And I think Bridge technology is a great example. Brings the entire Android application ecosystem into the PC environment. So this is a great example, and more such things are well underway. So Greg, your thoughts?
Yeah, so I'll just say I have hundreds of resources in software engineering, working very closely with Microsoft, every day, all day, every night, with the core internals of Windows optimized for our platforms. We co-developed this HGS Plus capability that we have talked about, which provides machine learning heuristics to the Windows scheduler with our E-core, P-core capabilities, so that we basically are looking real time during execution of Windows and applications on Windows to assign those threads to the most optimal cores at the right time. And then even our one API compiler, if you use it to compile capabilities that you run on Windows, you get a 10% performance boost over other compiler capabilities. And then my team also, we do a lot of work helping with the benchmarking to make sure that all the graphics performance, meets all the performance requirements. We run all the Cine benchmarks as well to tune things up to get the optimal power performance efficiencies out of the platforms. My team does all the BIOS, all the firmware. We work very close with all the vendors, Linux community, Microsoft, to make Android, Chrome OS, to make sure that we have secure firmware. We digitally sign all of our firmware. Microsoft's a big adopter in Azure Cloud with SGX, and they have many applications running securely in using the secure enclaves, our trusted execution environments in Azure Cloud. So we have a very, very tight partnership with them, not just with Windows and the PC. And as Pat mentioned, the bridge technology, we call it Houdini because we did a bunch of magic to basically allow those Android apps. And I mentioned in my talk the Windows subsystem for Linux version 2, which lets you run a complete Linux distro. So we run an actual Android distro into that hidden virtual machine on Hyper-V. And then when you load those applications into Windows, they actually sit on the Windows file system. So you just launch them like you normally would, but they actually execute in that Android OS that's in that Windows subsystem for Linux. So we just make it completely transparent. There's no big performance hit. We do lots of acceleration with the graphics to make it a good user experience, including for Android games. So this is the kind of close partnership we have with Microsoft. We've had it for years.
So out of everybody in the room, everybody had asked a question. We had a couple of minutes left and they said, time for one more. I managed to get my foot in the door. Sorry, Paul. I jumped at the gun there. And I asked more specifically about offering x86 IP in Foundry. Now, my thought at this point is, well, okay, they've said they're going to be offering x86 IP, but they haven't gone into details, what exactly that means for partners, for potential customers in the future. I specifically asked, you're spoken about offering x86 IP in Foundry services. Could you go into detail? Will Intel offer x86 IP in the form of ISA licenses, instruction set licenses, core licenses? And will the IP explicitly be manufactured at Intel, or can people use it in other foundries? Beyond that, I also asked, is there going to be an appreciable lag between the x86 IP that Intel designs internally and the x86 IP that it offers to customers through Foundry services? Pat had a good answer here.
Yeah, so a lot in that. So let's tease it apart a bit. What we've said is we are going to make x86 cores available as standard IP blocks on Intel Foundry services. So if you founder on Intel processes, we will have versions of the x86 cores available. I do say cores because it's going to be based on the cores that we're building, E cores, P cores, for our standard product line. So we'll be making them available. So you could imagine an array of E cores or P cores as a Xeon-like product that's combined with unique IP from a cloud vendor. That'd be a great example of where we'd have such what I call hybrid designs. It's not their design, it's not our design, it's bringing those pieces together. We're working on the roadmap of cores right now. So I'll say which ones become available, big cores, little cores, which ones first, the timing for those. Also, there's a fair amount of work to enable the x86 cores with the ecosystem. And as you all know very well, the ARM ecosystem has developed interface standards and other ways to composite the entire design fabric. So right now we're working on exactly that. And a fair amount of the IP world is using I'll just call it ARM constructs versus x86 constructs. And these are interrupt models, things like memory ordering models, and there's a variety of those differences that we're haggling through right now, to know, and working with customers, right? We have quite a lot of interest from customers for these cores. So we're working with them, picking some of the first customers, and we have a range of interest from fairly embedded like use cases up to HPC use cases with data center and cloud customers somewhat in the middle of those. So a whole range of different applications, but we're working through the details of that now. We clearly realize the criticality of making this work inside of our design partner and customers' EDA environments and the rest of their IP that they're bringing to the discussion. Does that help to frame it better? Yeah, and then the lag side, there's going to be minimal lag, and the idea is that for instance on my IP teams internally, they act like a Synopsys IP team, right? Because they're delivering, for instance, an E core or P core to the Xeon design team or to the Meteor Lake design team, whichever one it would be. So largely, as those cores become available, we're going to be making those available to our internal teams and our external teams, somewhat, coincidentally going forward. So, there's not a lag, right? We're making the IP available, and as customers start, getting firmed up in their design approaches there, we'll be, I'll say, I think more I'll say more mature to answer your question, but we do not expect that there's any meaningful, if any, lag. And hey, again, look forward to seeing you all in person again. I hope that you're feeling today like, what's old is new again, right? Many of the characteristics that, Intel was famous for in the past, we've lost some of those genetics. We are rebuilding those in real time. I think Intel On today was a good example of that step forward. And we look forward to building on the great relationships with many of you as we look to the future. Today was a great day for geeks. Thanks for joining us.
So ultimately, this is kind of what a roundtable with somebody like an Intel CEO looks like. It's just a bunch of press in a room. Everybody typically gets one question. I mean, none of my questions were like pre-vetted by Intel or anything. It was a free-for-all for everybody involved. And I managed to get a second question snuck in there. That's pretty rare. Though we have seen in places like CRN, they're being able to get full interviews with Pat. I don't know if that's ever going to be on the cards in the future. We'll see how that goes. I have kind of thought about what I would be asking Pat in an interview, because when I interviewed, say, Jim Keller, it was all about Jim Keller, the person, and his philosophies and how he operates. When I interviewed Mike Clark, it was a lot about Zen and the stories behind Zen. When I interview Lisa, it's a lot about product and product roadmap. She's right in there in the details, getting her hands dirty with all of that. So it's good to ask her something like that. With Pat, because Intel is, in his own words, kind of in a rebuild and reinvestment mode, the questions that you would ask Pat to get more information out of him tend to be more holistic in nature. And I know there's a portion of my audience that would like me to ask him, every bit of detail about what's coming in the future. Now, as you do more and more of these interviews, you slowly learn what people can and cannot say. And usually asking about future products is like a big no-no. Asking about, say, future predictions and the way things are moving, that's usually acceptable, as long as you word it in a way that makes it more, I'm going to use the word again, holistic rather than specific, which I know is not what specific people want to hear. But ultimately, that's the kind of cards they play, and you have to work with that and do your best as an interviewer to get the most out of the interviewee. But we're still, if you're watching this between Alder Lake announcement and Alder Lake launch, we've got reviews to come. I've got lots of stuff being tested over here, and you can't see it for reasons you all well know. But yeah, stay tuned for that launch. My main specification here is I would like to get a chance to actually speak to Pat face to face, for a good half-hour interview. And if that happens, if I do manage to snag that and I'm able to reach out to all of you guys, start thinking of your questions, or put them in the comments below. I'll definitely have a read through. If you like this content, please don't forget to like and subscribe. We also have now a private Discord server. And if you want access to that, become a Patreon member and it will instantly add you as long as your emails are linked. You can join the Patreon for as little as $1.50 a month, and it all goes back into helping the channel. Thank you for your support.